Hey there folks, come on, let's get learning about matter and atomic structure for the ninth grade. Here's a quick introduction to matter. Anything that occupies space and has mass is defined as matter. In simple terms, matter is anything. Now that we've been introduced to matter, let's get a better look, shall we? To understand matter better, we've got to start at the basics. Today we'll be looking at matter and its significance, atom, its structure and significance, significance of elements and compounds, and some of the great minds behind the scenes. Let's look at how matter can exist. Matter exists in three states: solid, liquid, and gas. Now, how do we recognize these three states of matter? By looking at how the particles exist. Let's start off with solids. The particles in solids are very closely packed. Arrangement of the particles is orderly. Strong forces of attraction exist between the particles, and movement of the particles is confined to vibrating and rotating around a fixed position. Liquids. Particles are loosely packed. Arrangement of particles is disorderly. Forces of attraction do exist, but not as strong as solids. Particles can vibrate, also move freely through the liquid. This is because they are loosely packed. And finally, we have gases. Particles are very far apart, meaning much space exists between each particle. Movement of particles is random. Forces of attraction are very weak in gases. Particles can move freely. Collision between the particles is high. Collision means to collide into or to bump into. Now let's look at a picture that depicts these three states of matter. The first picture shows frozen water or ice in a solid state. Second is water in its natural form, which is a liquid state. And the third is water vapor, which is a gas state. Matter can change or interchange between three states. Let's look at this picture, which shows us how matter can change. Solids to liquids is known as liquefying or melting. Liquids changing to solids is known as freezing or solidifying. Liquids changing to gases is known as vaporizing or evaporating. Gases changing to liquids is known as condensing or liquefying. Solids directly converting into gas is known as subliming. It also shows how the particles are placed. Solids, particles are very, very closely packed. Liquids, they're loosely packed, and gases, they're very far apart. Now let's have a look at the atom and its structure. An atom is the smallest particle of an element. It is also the defining structure of an element. Here we see the basic structure of an atom. It consists of a nucleus, which has neutrons and protons, which are circled by electrons. The electrons move in circle around the nucleus in paths known as orbits or shells. Here's another picture that gives us a better idea. Here we see the nucleus in the center, the protons and the neutrons, and the electrons circling around it in orbits or shells. Here's a thought. Do atoms exist alone or do they cluster together? Well, they can exist alone and in groups as well. When two or more atoms group together with the help of chemical bonds, this structure is known as a molecule. Here's how it looks. When atoms or groups of atoms have a positive or a negative charge attached to them, that structure is known as an ion. This is how it looks. Next up, let's take a look at the electronic structure or configuration. What is this electron structure or configuration? Well, it's the arrangement of electrons in the shells or orbits around the atom's nucleus. Remember that picture we saw of the atom structure with the nucleus and the electrons going around it? Yeah, so electron configuration is simply the number of exist in each shell or orbit. Here's a list of how many electrons can exist in each orbit. In the first shell, there are 2. In the second shell, there are 8. In the third, there are 8 or 18. And the fourth, there are 36. Let's look at another picture to get a clear understanding. In this picture, we see the nucleus in the center, the first shell containing 2 electrons, second shell 8 electrons, third shell 18 electrons, and so on. Now that we know the basics of the atom and its structure, let's go back to matter again. Now we'll see how matter can be classified. Matter is divided into 2 basic types, the first being the element. This is the type of matter which cannot be simplified or changed into 2 or more elements because it has just one simple type of matter. The example we see here is gold. Gold can't be broken into different elements because it's just one single element. The next type of division is a compound. This is the type of matter which can be simplified or changed into 2 or more elements. This is because it contains more than just one simple type of matter. The example we can talk about here is water. It has 2 parts of hydrogen and 1 part of oxygen. Hence, it can be broken down into hydrogen and oxygen. Pretty simple, isn't it? Now elements are further divided into metals, examples being iron, gold and zinc, etc. and non-metals, examples being carbon, oxygen, sulfur, etc. Compounds are divided into ionic compounds. To understand this, let's try and remember what we read about ions. Yeah, they are the atoms or groups of atoms which have a positive or a negative charge attached to them. So, an ionic compound is a chemical compound in which the ions are held together in a lattice structure. Here's what a lattice structure looks like. The forces that hold these ions together are called electrostatic forces. These exist between positively charged bodies. These compounds have higher boiling and melting points and are very brittle, which means they are easily breakable or can easily be shattered, though they are very hard in nature. The other type of a compound is known as a covalent compound. The term covalent was first used in 1919 by Irving Langmuir. The prefix co means to exist jointly or to be associated or partnered. As the name suggests, covalent. This kind of chemical bond is characterized by sharing of paired electrons between the atoms. Now let's stop for a moment here. Now all this talk about compounds makes us think of another word, a mixture. So do they hold a different meaning? Sure they do. Though they sound pretty similar, they're very different indeed. Both are made up of different stuff. Now the difference lies in how these different stuffs are combined. So what's a mixture then? When 2 or more things are blended but each retains its own identity or property, this means the end product of a mixture is similar to the properties of the things mixed. The example we can look at here is salt added to water. What do you get? Salty water. Salt retains its property of taste and water retains its property of being a liquid. So what are compounds then? When 2 or more things are blended to produce a completely new thing with new properties. Hence, the end product will be very different from the things blended. Example, iron exposed to oxygen. The result is rust. Now, rust does not have properties of either iron or oxygen. Now let's get a better look at the classification of elements and compounds with the help of the periodic table. The elements in the periodic table are arranged in order of their atomic number. This is to ensure the elements with similar properties or characteristics are grouped together. Like any table, periodic table has rows called periods and columns called groups. Let us talk about what the periodic table signifies. Now the easiest way to understand this table is to learn about valence electrons. Now what are these valence electrons? These are the electrons that can participate in formation of chemical bonds. These electrons are present in the outermost shell or orbit of an atom. These electrons are important in determining how the atom reacts chemically with other atoms. Electrons have the ability to absorb or release energy in the form of photons. When an electron gains energy, it moves to the outer shells, and when it loses energy, it moves to the inner shells of the atom. Now let's picture a hot air balloon. If the hot air supply is continuous, the balloon rises. But if the hot air is cut off or decreases, then the hot air balloon descends. Similar kind of a concept applies to the electrons gaining and losing energy and their movement to the outer and inner orbits. Now these valence electrons determine reactivity, bonding strength and electrical conductivity of elements, which means the passage of electricity through an element. Now that we know the valence electrons are pretty important, so let's go and look at the table. Starting off with helium, neon, argon, krypton, xenon and radon. These are known as noble gases. This is translated from the German word Edelgas. This is to indicate their extremely low reactivity. This was first used in 1898 by Hugo Erdmann. Moving on, we have fluorine, chlorine, bromine, iodine and astatine, also known as halogens. This term was coined by the Swedish chemist Baron Jöns Jacob Berzelius. Its literal translation means sea salt come to be. This is because a sea salt-like substance is produced when halogens form a compound with a metal. Halogens are highly reactive and as such can be harmful to biological organisms in sufficient quantities. Next up we see hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur and selenium. These are known as nonmetals. These are considered poor conductors of heat and electricity when compared to metals. They form acid oxides when combined with oxygen. Moving further, boron, silicon, germanium, arsenic, antimony, tellurium and polonium. These are called metalloids. These are chemical elements with properties that are in between or a mixture of metals and nonmetals, hence the name metalloids. These are also known as semi-metals or semiconductors. Further down, aluminium, gallium, indium, thallium, tin, lead and bismuth, also known as poor metals or post-transition metals. They differ from the metalloids due to their significantly higher boiling points. These also fall under the general classification of semi-metals. Moving on, scandium all the way to mercury. These are called the transition metals, also known as transition elements. This means the element has an incomplete d subshell. Remember we talking about shells and orbits? Yeah, so these elements have incomplete shells and the elements give rise to cations. What are cations? They are positively charged ions. Now moving further, we see two groups. The first group is known as the lanthanides and the second group is known as the actinides. Now these two groups are known as inner transition elements. These elements are also referred to as the F block elements. This is because they have atoms of valence electrons in the F orbital. Moving further, beryllium, magnesium, calcium, strontium, barium and radium. Now this group of elements is also known as the alkaline earth metals. They are also referred to simply as earth metals. This is because they occur naturally in the earth. Antoine Lavoisier discovered that these are naturally occurring compounds and not metals. Remember we discussed about the classification and difference of elements and compounds? Yeah, so he discovered that they are compounds and not elements. Further down, lithium, sodium, potassium, rubidium, cesium and francium, also called the alkali metals. These are shiny, soft, silvery and highly reactive metals. Oxidation occurs rapidly in these metals Thus, they lose their lustrous nature very fast. My, that felt like one big table. Well, not really. All we need to do is go through the table a couple of times and we'll be able to master it. Now let's learn about some of the great minds behind the scenes of all the nice things that we've learned today. First up is John Dalton. His studies show that the atom is a small invisible ball. He also said that the atom can be created and destroyed. Now this is the story behind nuclear reactions. Next up, James Chadwick. He proved that neutral particles called neutrons existed in the nucleus of an atom. He also found that half of the mass of the atom is contributed by these neutrons. Here's a picture of how James visioned the atom. J.J. Thomson. He discovered the electron and he also described the atom as having positive and negative charged particles. This is a picture of how J.J. Thomson visioned the atom with the positive and the negative particles. Ernest Rutherford. He discovered that protons have a positive charge. Also, that most of the atom is concentrated in its nucleus. Here's his picture of the atom. And finally, we have Niels Bohr. He discovered that the electrons move in shells or orbits. Remember the picture we saw earlier about the atom? Well, that is what Bohr discovered. He also said that the orbits are spaced at fixed positions away from the nucleus. Great going, guys. We've completed this chapter. Here's to learning something new. Thank you for learning along with me. So it's goodbye until the next chapter then.